So in this video, we are going to discuss about TCP/IP protocol stack. Now, what is this exactly TCP/IP? So if you remember in our previous sessions, we discussed about OSI models. OSI, Open System Interconnection, it's a reference model which is going to tell how the communication process happens between two or more networking devices. And we have seen this process is further divided into some 7 layers, and each and every layer is going to define a set of functions which happens in our network. So like we got some top 3 layers. If you remember, we discussed this OSI layers, where the top 3 layers will be considered as your. So in this video, we are going to compare this OSI model along with TCP/IP here. So exactly, we are not really doing anything about OSI. OSI model gives a very good detailed description on how the communication process happens. But when it comes to practical implementations, we use TCP/IP because if you remember, the entire internet works on TCP/IP, which means not only internet, even if we are using a TCP/IP protocol stack in practical implementations. In this session, we are going to discuss about some of the important TCP/IP protocols which we use in our network communications. Again, this TCP/IP model is again having 4 layers, but again it defines the same thing what defined by OSI in their models. The only difference is these 3 layers, the application, presentation and session layer, combinedly referred as application layer in TCP/IP language. Okay, and transport layer will be referred as host to host layer, network layer referred as internet layer, and data link layer, physical layer, combinedly referred as network access layers. Now, regarding your CCNA certification exams, or if you face any questions on OSI, if anyone asks you, let's say router works in which layer, so we are going to define it as network layer, but we don't really tell as internet layer, because still according to OSI we refer the reference model is still the OSI model, and OSI having its own protocols, but in practical we don't use OSI models. In practical we use TCP/IP. So the process when it comes defined by any layer like OSI layers or it can be TCP/IP layers, it remains the same. There's no change. So they all tell the common thing, how the communication happens between the networking devices in different layers, divided so that we can easily understand in which layer what type of function happens. But in practical we implement TCP/IP. So we're going to see some specific layers like a processor application layer. The first layer, combinedly it is responsible for initiating the application, and then it also represents the format for the data. And then session layer means it creates, maintains and terminates sessions. So these 3 processes are combined in this application layer, and there are some specific protocols which are responsible for doing this. Like if you remember, when you're accessing internet, there is a protocol called HTTP. So when you access internet, web browser is application, but backend there is a protocol called HTTP which works on logical port number 20, sorry, port number 80, which it's a HTTP service which allows you to access web pages. If you want to send and receive web pages, actually we use a web browser program, but the backend protocol inside the network which allows you to access web pages is HTTP. And again, when you're sending and receiving the files, there is a protocol called FTP, works on port number 20, port number 21. It will allow you to send and receive the files. And when you talk about files as well as folders, we can say set of files. And there is a protocol called SNMP, POP3, IMAP. These are all the TCP/IP based protocols which are responsible for sending and receiving the mail services. If you are hosting some mail servers, then these are the backend protocols which will allow you to send and receive the mails. Similarly, if I talk about other protocols like Telnet, which works on port number 23, Telnet allows you to access a remote device. If you remember, Telnet is actually a protocol or application which is going to allow you to access a remote device. Like if I take an example, I have a router here, I have my LAN, and I have one more branch office connecting in a different location. Probably this is my branch office in India, and maybe I have one more branch office in Dubai. So now I want to make sure that from by sitting in my LAN in my place, so I want to access a remote device. Remote device means the router which is somewhere in Dubai. So it's not in my location. So what I can do is, like, by sitting here, I can access this device. So I just need to go to command prompt from this PC, and I have to type one command called telnet space IP address of that device, assuming the IP address of the router 2 or Dubai router is 10.002. Just we need to type this, and after that it is going to ask some credentials, username, passwords, depending upon the configurations on the Dubai router. And once you provide some appropriate credentials, you will be able to log in and access the router as if you're sitting on the router directly. So this telnet is one of the most common application in the production networks, especially if you are a Cisco engineer, network engineer working on Cisco or any other platforms. You will be majorly accessing most of the devices via telnet. Maybe you're accessing the routers, and you're accessing some switches, and you have some company firewall. You're also accessing the company firewall by sitting on your PC remotely. So we don't really do everything via console. Remotely we do it. In the later on sections in our CCNA topics, I have given some examples how to do telnet also. So probably you'll see these things in the coming sections practically. But this here in TCP IP, we are not getting into much practical oriented, but these are the things which we generally do in our normal things. Like, these are the inbuilt protocols inside the TCP IP. And apart from that, I can say the remaining protocols, like we can say TFTP protocol. TFTP stands for Trivial File Transfer Protocol. Okay, so it's a stripped version of your FTP protocol. Now the difference between FTP and TFTP is FTP uses TCP protocol while at a transport layer, whereas TFTP uses UDP for transporting your data. So TCP UDP differences we'll see in our next layer. There is a basic difference, like the functionality wise. There is some basic differences between TCP and UDP. We'll be getting into that. Now the one main difference is TCP, this FTP will allow you to send and receive the files as well as folders. You can see the first point here, as well as it will allow you to access both directories and files, and uses TCP for the data, and here it uses UDP for the data. Now, where exactly this TFTP protocol is used? So FTP I can understand. Okay, whenever I'm doing some downloading or sending and receiving some files, FTP is involved in the backend process. FTP servers, even in the LAN, when you're accessing some files, FTP is the backend protocol. Whereas TFTP protocol is used in some special cases. In some backup, in our CCNA, we'll see something topic called backup of your iOS, backup of your configuration, backup and restore actually. So we have a separate section dedicated for this. So backup of iOS is actually loading the iOS inside the router. So before I come to the Cisco way of implementing this TFTP, using the TFTP, I can give one more example in Windows platform. If you are much comfortable with Windows, if you're already a Microsoft engineer, you know there is a process called remote installation service. So remote installation services as per 2003, so now in 2008 servers they have changed some names, but remotely installing the operating system on the PCs through the LAN. So this is what exactly the process. So through the LAN, I have a server here, and this server is having the operating system image. So just like we boot from CDs, similar way we are allowing our PCs and devices, they are not going to boot with a CD-ROM. In general, when we install the operating system, we use CD-ROM. They are going to boot from the LAN, which means the first boot device will be LAN. So now whenever you boot, it is going to send a broadcast request, and there is some DHCP server. There are a lot of things involved in the process actually. I'm not getting into detail into that. So now it's going to send a request, and based on that request, this device is going to get the iOS image. Now automatically all these computers will be installing the operating system through the LAN from the server. And the backend protocol responsible for doing this is done with the help of protocol called TFTP. TFTP is a backend protocol responsible for this. Similar way, when we get into our Cisco networks, we have a separate session dedicated for that. This we'll see practically. A backup of iOS, backup of config. This is something what our CCNA covers. Definitely we'll be doing this, but this is something what we don't do. It's a Microsoft related technologies. Okay, so we don't get into that, but just a understanding, just a comparison, I can say. Now here also, what we can do is we can connect a router to a PC, and what we can do is we can take the backup of the operating system of the router into my computer. Even I can restore the operating system from the computer to the router. Even I can take the backup of the configurations. So this entire process can be done with a protocol called TFTP, because TFTP is the backend protocol responsible for that. So we'll be seeing these things how to do. Don't worry about that particular part. We have a separate session dedicated for that. So but this is what exactly this type of scenarios where TFTP is in practically used. Now the next thing is I'm just coming to this DNS service. DNS service is also we are using in our day-to-day activities when we access internet. Internet domain naming service or domain naming system. It resolves the fully qualified domain name with IP address. Okay, what is exactly means is, if you remember, we access internet when we need to access internet or access any web page on the internet. So we need to type something called URL path. We just generally type www.abc.com, some website name. So when you type this website name, automatically you will get a web page if it is available on the internet. Okay, but now this, in general, we also know that the communication inside the network happens based on the IP address. The devices, each and every device will be given a specific address called IP address. They are not identified with the names here, what you can see here. So each and every device will have a unique IP address. So this DNS service is similar to your telephone directory, your mobile phone. Like if I take an example, I want to speak to my friend, some friend XYZ, and if I want to speak to him, I already have his number something 1234, his mobile number, and it is saved that number with mapping with a name. So if I want to speak to my friend, so with his name, I don't need to type the number, I just need to search his name. Okay, just search and then dial. So when you are dialing to the name, it doesn't mean that you are dialing to a name or it's going based on the name, but internally there is a mapping of name to number, which means when you are dialing, it is not dialing to the name, it is dialing to the number which is mapped with that respective name. The same thing DNS is going to do in our production networks. Now internally the entire process happens based on the IP address internally. But remembering the IP address of each and every device on the network is not an easy thing. Like let's say I'll say I want to access yahoo.com, I want to access some google.com, I want to access some specific websites on the internet. So no one remembers the IP address, even I don't. I just need to type. So no one remembers the IP address in general, but internally there is a mapping called mapping of this specific name mapped with some respect to IP address. Okay, Google, let's say some address. Okay, I'm just taking some random address. So it is done by a specific server called DNS. So when you get into our if you get into the IP address config, in general, if you type ipconfig/all, if you're accessing internet, let's say if you're accessing internet, so if you're connected to internet, a public network, we generally assign the IP address, and also we assign the subnet mask, and we also assign the gateway address. Like I can show you that. So here you can see I just got into my command prompt here, and in that I type ipconfig/all, so I can see what is an IP address here. Let me show you. So here you can see one option called DNS server. So the DNS server is probably, if you're using a home internet connection, it is the IP address of the server, maybe on the service provider network, or if you're in a production network, it can be the IP address of the DNS server. Means if you're working in a production network, the internal company organization will have their own DNS servers. Again, they will map. So you can have multiple DNS server configurations also. So all this information you can see, this is the IPv4 address which I'm using, and the subnet mask, and the default gateway address, and then DHCP server information, DNS server, who is using DNS, all this information. So without having this information in general, you cannot resolve the name to IP address. So which means whenever a request comes something like this. It will automatically redirect to the DNS server. User says, I want to go to yahoo.com. Okay, you want to go to yahoo.com, no problem. I don't know who is Yahoo, but I'll send the request to DNS. DNS is going to check the database. It says that okay, www.yahoo.com, the IP address of that device is this. So now the user, when it sends a packet, it sends with the destination address as 202.111. Okay, but internal process is done based on the IP addressing. But to make our job more easier, we map that particular IPs to respective names, and this is what we call as fully qualified domain name. This is what we call as fully qualified domain name, where the first www will be the alias name and specific server's name. So based on that, the next protocol which we'll be discussing here is DHCP, Dynamic Host Configuration Protocol. And this protocol also we use in our production networks, which will automatically assign the IP addresses to the host. Okay, so let me explain you how DHCP works. So DHCP is a automatic assigning the IP address. Like maybe you'll see in the production networks where you have thousands of computers. Maybe you have some hundreds of computers, thousands of computers. You got a very big network, and going to each and every device and assigning the IP address is something not really possible. Even if you try to do that, you may have some issues like IP address conflicts, and probably you may not be able to assign it properly, and sometimes suddenly some IP addresses change in the IP addressing scheme. Again, you have to go to each and every device changing. It's really going to increase the overhead on the administrator. So to minimize it, what we can do is we can have all our computers in the LAN, which are mostly client computers. Client means the end users will be using all these computers, and they really don't have any privileges to, maybe generally we don't give any privileges to assign or change the IP addresses. Okay, and also we configure a specific server called DHCP. It can be a Linux servers, even you can use a Linux servers, or it can be a Microsoft servers, Windows server operating systems 2000, 2003, 2008. Even you can make a specific router to act as a DHCP. So we have this in our CCNA. We'll be discussing how to create a router, to make a router to act as a DHCP server. We'll be seeing that, some basic configurations for that, but in general we don't do that unless it is a small size networks. So now whenever you power on this PC, so on this PC we are going to give the option called obtain the IP address automatically. So you can find this option in our network interface card here. This is my LAN card, wireless adapter which I'm using. And if you go to TCP IP v4 properties, you can see I have selected obtain the IP address automatically and obtain the DNS server address also automatically. So when you check these options, it means that you are leaving to other device to provide the IP address and provide all this information, not only IP address. Using DHCP, you can provide IP address information, subnet mask, and you can define who is a gateway, and also you will get the information about who is a DNS server and or you can define what should be the DNS server to convert the name to IP address. Now based on this, we need to select this option, and once you select this option and when you install the operating system for the first time, this option is by default enabled, means by default that option is selected. So once you do that, automatically whenever you power on this PC, it is going to send a broadcast message. It's not actually sending to only DHCP, it's going to everyone. Everyone means this message go to each and every device within that broadcast, within that LAN we can say. Now what it is going to send a request is, this is my MAC address. It's going to say, hello everyone, this is my MAC address. Assume the MAC address of this is ABCD, something MAC address. It's actually a 12-digit number, so I'm just writing only 4 digits here. So I can say ABCD, ABCD, and ABCD. Assume this is the MAC address. So it's saying, hello everyone, this is my MAC address. Is there anyone who is having the authority or who can provide me an IP address? Now this request goes to each and every device in the production network, in the LAN, but all the remaining devices will ignore this message because they cannot provide the IP address, because they are not the DHCP servers. But now the DHCP server will listen to that message and replies. So now on this DHCP server, what administrator, again you have to do some configurations for that. It's not going to take a DHCP automatically. So we are going to do some configurations on this server where we'll be defining the range of the IP address. Range means, let's say I will define that the IP addresses to all my devices, whoever requests, should be given in between 192.168.1.10 to 192.168.1.100. Means not compulsory, it should be C class, it can be any class, any range, and any number of addresses depending upon the size of your network. And even I can tell what are the addresses I should exclude, which should not be used. Like let's say I have a router which is using 192.168.1.50, let's say. I don't want any device should get the same address. Or maybe I have some firewall using 192.168.1.100. I can exclude the addresses within that range, and even I can do some bindings. I can tell this MAC address, whatever the MAC address, should always get this IP address, specific IP address. So all these configurations, even I can tell what is the DNS server information, who is a default gateway. All this information will be automatically configured. It's something configured by the administrator on the DHCP server. Now this complete information, whenever a user requests, the device request, when it is replying, it is going to check the available addresses within that range. Let's say 10, 11, 12 is already given to some specific devices. So it's going to assign the next available IP address, 13, 192.168.1.13. Now this device will be getting that, using that IP address as long as this device is powered on. Or even you can have some lease period, the default lease period, even we can change. So based on that, it will automatically renew the IP address if required. So this is something which is more common in the production networks when you get into that. And this is what we call as DHCP protocol, which is responsible for automatically assigning the IP address to the devices. And it works on port number 67, 68. These are the logical port numbers used by DHCP. Okay. So let's move on with other protocol. One more important protocol which you may come across in the real production networks is SNMP, Simple Network Management Protocol. So this protocol is responsible for monitoring your network, simply monitoring. Because in the production network, monitoring is the major task which you need to do, especially if you are working as a level 1 or any other engineer. So it's going to be a little bit very difficult task. You need to monitor each and every device. So when you're doing some monitoring, it becomes very difficult for the administrator to go to each and every device and check the status of the devices. Because take an example, I got a big LAN network, big network, and I have some more than 500 devices connected in my LAN, and assume that I got some more than 20 switches in my network, and I have some multiple routers. Maybe I have some 4 to 5 routers which is connecting to all the different locations, and I have some firewall, and I have some configuration servers, web server, FTP server, lot of things. When you come to production networks, there are many things running on the network. There are many devices. Now it becomes very big task for administrator to manage and to really come to know in case if something happens where the problem is. So let's take an example. The connectivity to the router is down. Now, suddenly this router is down and the users complain sitting here saying that I'm not able to access the resources on the other end. So now you know that even maybe you'll not come to know that the problem is on the router, because when user complains, now you need to do some troubleshooting layer by layer. So when a user says I'm not able to access a specific internet, so now the problem can be on the PC program, the problem can be on the connectivity connecting to the LAN, or the problem can be on the switch, maybe the switch is powered off, and the problem can be on the router to switch to router connection, and the problem can be on the firewall also. Now there are many devices involved in the process here. Now when you go from basic troubleshooting from level wise, you will check level 1 device connectivity, you'll check level 2 device, and you'll check the level 3 device, firewalls, routers. It's going to take very huge amount of time to fix this problem. Probably you end up troubleshooting, fixing. Maybe it will take easily 20, 30 minutes, 1 hour. Sometimes even it can take more than that depending upon the issue. And sometimes you will have a very small issue, and the issue was with your software program. Actually there are some virus programs, due to some program virus programs, or due to some application that is actually denying that, or it can be some problem on the firewall which is denying some rules, or it can be on the router, there is some routing issue, or it can be on the switch. Now, figuring out the exact problem will take huge amount of time in general in the production networks. So now, how to overcome this? So now to overcome this, we can some do something called monitoring tool. We can use some third manager tools, like you have some small programs like outsub gold and op manager. We have some and some high end tools like HP OpenView, high end monitoring tools, solar winds. These are very high end monitoring tools which are generally used by the production networks. And what these programs are going to do is, we need to configure one server. Server means any one computer, yeah, not compulsory to be a server operating system, but this server is going to act as a SNMP server. Again, in the same server, you can run other services, like you can run DNS service, you can run DHCP. It's not really compulsory that you should have a separate DHCP, separate DNS. One single server, you can run multiple applications or multiple services at the same time. It all depends upon the load or amount of traffic or amount of request going on that. So as long as that server is capable of running, supporting these things, so you can run that. So anyway, we don't really need to talk about much onto DNS DHCP. We did that already. So now we need to install one application on this. So whatever the applications I discussed, depending upon the company, organization, they generally use any one of the applications. Okay, so we are going to run that application. So nothing but we are going to install and run that application. So when you're going to run that application, the backend protocol of this application will be SNMP protocol, which is going to gather the information of each and every device in the network. Means it's going to each and every device in the network. It's going to contact each and every device, and it's going to bring all the information including a lot of things, like it can be the information about the complete hardware, the operating system install and number of ports, which port connecting to which device. It's going to build the complete logical topology. Let's say this is the screen of your SNMP server. This is my SNMP server. You can see the complete logical topology of your network on the screen. And in case if something goes wrong, let's say the connectivity to the router goes down, automatically you'll get alert message on your computer. You can see on that. Even you can, there are some programs which will allow you to automatically generate an email if something goes wrong, or suddenly there is a high processing utilization, or there is a router which is using the CPU processing something around more than 80%, which means there is some issue over there. So automatically you get these alert messages by using this. You can trap these messages. Not only this, you can trap almost each and everything depending upon your requirement. You can trap everything, but if you want to be more specific, you can define that specific things. Okay, so the backend protocol used here is your SNMP protocol. SNMP, simple network management protocol. Okay, so this monitoring is the day-to-day activity which generally every network engineer will do. So mostly you are level 1 engineers, so you need to be very well aware of these monitoring tools, and that is something we really don't do that. But it's a very simple software which is mostly a graphical user interface, which is going to help you a simple task, and you can easily manage these tools. So having this knowledge, this is something what you will gain when you get into your production networks. So probably it's a very good thing you'll find in the production networks when you get into SNMP protocol. So like this, there are various protocols inside your TCP IP, and each and every protocol is responsible for providing a specific things. Like here I listed some few important protocols, but I'm not saying these are the only protocols inside the TCP IP. But these all protocols, we call them as application layer protocols because they work inside your application, so you don't see them. So inside the application. So the next thing we need to understand is the transport layer protocols, or according to OSI, according to TCP IP, we call it as host-to-host layer. And there are two protocols which are responsible for this host-to-host layer, TCP and UDP. So more on this we'll be discussing in our next video.